Okay, you guys, we're going to do parametrics. This is a BC topic. Am I short one? Are they all punched wrong? I probably didn't hit 3. My punch is over there. Okay, you guys, do you remember how to find f of x? I'm sorry, the slope dy dx if you're given parametrics? It's dy dt over dx dt. Well, let's just review a couple things. When is the object at rest? Now, that means it's totally at rest. It's not moving up. It's not moving forward or backwards. Dy dt is what? 0. And, it's an and, dx dt. So both must be 0. Okay? And generally speaking, this is one of the easiest parts of the BC exam because it's with a calculator, but some of you didn't use your calculator. And it's pretty simple. It's just doing something like this, and you use your calculator to find the derivatives. How do you know there's a horizontal tangent? Generally, how do you know there's a horizontal tangent? Dy dx is what? 0. Well, when is this fraction here 0? So dy dt is equal to 0. And by the way, you get points for saying those things. You get a point for saying dy dt is 0 without even being able to solve it correctly, which is kind of nice. When do you get a vertical tangent? When dy dx is what? Not 0, but undefined. That's a vertical line, so the slope has to be undefined. And so when does my dy dx become undefined? When dx dt is 0. And the problem that we've assigned out of this section is probably much harder than what's on the exam. So we'll do some exam problems as well. Okay, so you ready? You'll need a graphing calculator. We will have to switch our modes. And I don't have any. So if you don't have one, share. Because I'm using them in my first hour, so I stole them all. David, do you have your calculator? No? You have 2 calculators at your table? You know, and I've played around with a little bit of the iPad ones, and I have not been real fond of them. They're not very easy. Okay. Here's my x value, and I'm just going to get it out of here. X of t, because it's just too much writing, is t squared plus t plus 1. And y of t. Now, this is an easy one to find the derivative of either piece of this. Okay? And it asks, find the coordinates of the interesting points on the curve. The interesting points would be where there are vertical tangents and horizontal tangents. And unfortunately, also where the curve intersects itself, there is no intersect button. So that's a problem. You actually have to just do a trace. That's the only way to do it. So my calculator is not in the correct mode. I'm going to put it in the correct mode. So I'm going to go to mode, and I want to be in parametrics. Okay, so oops, I went too far. Parametric, we go over. Later this year, we'll do polars, and we've done sequences. So now you'll know just about everything. This horizontal, well, I haven't shown you about the imaginaries. We could do that after the exam. And this breaks into a horizontal screen, or you could put your graph and your tables on the same screen. So you'll see on one side of the screen a graph, one side a table. It's up to you. I don't like it because it's just too small. Okay, so my functions are not going to be correct, so I'm going to have to put them in because it was whatever I did last time. So I'm going to clear that out. And put this in. So now this becomes t squared plus t plus 1. And my y value is 3t to the fourth. I got to do a little fixing here. Minus 8t cubed minus 18t squared plus 25. Oh, I hate that when I do that. Thanks, guys. We'll try this again. 3t to the fourth. I always forget because I'm in pretty print. I forget to do that. That's the downside of having the fancy software. And I never look at what I do because I type like that too. I should be okay with the t squared. Plus 25. Well, the problem is going to be the window. Now, if anybody's wanting to buy a new 84 calculator, my personal preference would be to get an Inspire. But if you want an 84 calculator, they have new ones out that are in color, and they're the same price as the other ones. The downside on those is more upsides than down. I think it works a little slower than your regular 83, 84 calculator. But it also has a rechargeable battery that you just plug in. So you don't have to buy batteries again. The 84 does now come in color. I just saw it last Friday, which I forgot to do. Okay. Honestly, I don't know what the window should be. I want to look at the big picture, and I want to look at interesting information. That's why, guys, I only have assigned one problem because one is tedious enough. Because you got to get the right window. I have some tables here, but let's actually look at the table. And the table is, let's go to the second table set. Because this is the easy way. We'll start at 0. We'll count by ones. I'm not zooming in on anything. And I go second table. So the x's are going to do this. 1, 3, 7. I'll go ahead and get a picture of that. Because I got to figure out what I want to set my window at. Zoom fit does not always work. And the y's are going to go from 25 to negative 110. I'd like to see the whole picture first. And if I go up, I'd like to look at some negative numbers. Okay, so let's take a picture of this. And so on my x's, this is my thinking. My x's are going to be from, I've got to go 3, 21, 43. So it looks like they're going to be positive. Are they ever going to be negative? Look at the function. No. It's never negative. And by the way, that's been an AP question to show that that's never negative. Okay, so you want to go 0 to 47 on the x's? Okay, sounds good. And what about the y's? The y's went down to negative 110. 115, how about negative 120? Up to, well, that's awfully big. That's only, yeah, I mean, 450 here for 5. So we'll make it 450. That might be too big. And what do you want the time then to be between? Don't ask me why. I just switched kind of notation since I did. Let's try negative 2. And if we go up to 5, that will give us a pretty wide range. I haven't practiced, so I don't know. Now I'm going to move this again. And so my t's are going to go. So I'm going to go to window. And the t-min, I want to be at negative 2. And I go to 5. That happened to be by chance. If you make your step size too small, it will take too long because this actually gives you time. And then my x-min, 0. And we said 47. How about we just make it 50? Because I like nice numbers. And let's turn the y scaling off because it's going to be such big numbers. You know, if you put 0 in, it won't scale it at all. So that's negative 120. And y max will be 450. If we got to make it bigger, we make it bigger. Crap. Oh, I've got that circle trace on, so it's slow. Plus, I want my window, I want my time further back, so let's do negative 5. We'll see what happens. And then I forgot that I had that little circle trace there, and it just graphs so slow. So let's just make it a regular graph, because I don't care. Hey, guys, you get it over there? You have the graph? There's my window. Well, I made it negative 5. There it comes. that. Nice. I get the big picture. You want me to go back to my window? Okay. I use the tables to make good guesses on what I should put in for the x and the y values. So when t was negative 2, x was only 3. But I had to fool around with the tables. That's why I've got two pictures of tables there. And then y max, I put at 450. I'm glad I went down to negative 120. I wouldn't have seen the little minimum. There's a minimum there, isn't there? Okay, so I'm going to go back to my graph. I want to take my picture of it. And let's just drag it over here. And we can analyze some things. But what might be interesting, and this is what you have to do with the one problem I gave you, is to see what happens here. It's coming down. If I don't draw it to scale, it's coming down doing that. That's what it's doing. And there's a minimum here. So what should be true about your slope at that point? Oh, there's another one here. These are relative. This is absolute. That's a relative max. And then we have a vertical tangent. Looks like just right here, right? So dx dt will be 0. And at these three places, dy dt equals 0. Let's see what the calculator does, because I forgot. I did forget. We'll zoom in on that in a little bit. Actually, I could just zoom in on it rather than figuring it out again. But I'd like to see what dy dx is or dy dt is right there. So we can go, will that work? But I don't know where that is. So guess what? I'm going to have to trace. Oh, you know what I don't like is my t-step is small, so I'm going to take my t-step and make it 0.1. Then it's not so, it doesn't take so long. Now I can trace it. I still don't see. My y is still way too big. It's going to come down here pretty soon. X is 8. Oh, 367. There it is. And unfortunately, I don't know if you have to kind of estimate where it is. If you to get a better answer here, to get that bottom, guess what? I'm not going to see it. I'm still over here. Okay. The only thing I could do would be to make my y value negative a little bit small. I can kind of see it. Can you kind of see it there? That's pretty close. Well, let's see. Let's see. We'll do second calculate, and we can look at dy dt. Is it close to 0 there? Press enter. Dy dt, can you guys see that? 13.57. I press second calculate, so I'm going to trace, and I want to get over a little more. I'm not at the bottom, because what should dy dt be? So it looks like the t value is 3.2. So I don't know if that messed me up when I did this. And I went and looked at dy dt, so press that, and press enter, because there is no dy dt there. And I can't really see that very well, but let me try second calculate, because I haven't tried this. You just estimate, and I have 3.2. And I can't read that. If I make my window bigger, I can read it, but that's the idea. Okay, so shall we zoom in? Should we actually literally zoom in on that? You guys know how to do a box zoom? The little circle here. Oh, you know the window. Well, let's pretend we don't. Oh, nuts. Where's my cursor? Actually, it's easier to do the window. Now, Ori already found it for us. Where's your window for it? Pretty small. Let's make it 0. What's x max? Let's make it 2. I like nice numbers. positive. Let's make it 0. So let's make it 40. You ready? Graph. Oh, that went so fast. I want to slow it down, so I go back to my window. I'm going to take my cheese step and make it 0.05. You see why there's only one problem sign? Okay, there it comes, and there it goes. Pardon? Yes. Notice how long it's taking me to do one problem. Let me bring my calculator back up. You have to have a negative t-value, and it's doing this. So I go to my window. Your t you want at -5, or you won't get that loop. There's the window. I'm gonna copy it over here, and I'll copy the next part of it too. Okay, but let me give you the other stuff. Wait, Alex, let me give you the handout. like what we just did. Okay, it says for A, find all values of t at which the line tangent to the path of the particle is vertical. So if you want a vertical tangent, how do you find that, Zach? Vertical tangent. What do you look for? The x dt is 0. Now, if a graphing calculator is allowed, are you going to try to solve that by hand? No. Now, do they give us the domain? I think they do. Okay, so it's 0 to 1.5. And you must justify your answer. Guess what I did? I always justify my answer first because that tells me what to do. I know I have a vertical tangent when dx dt is 0. 1 point. And then 1 point for your answer. It's okay if you skip the dx dt equals 0 and you make this statement, the 14 cosine of t squared. That's fine too. Personally, I would write dx dt as 0 first. Now, do I have to do it, or are you just going to give me answers? I know I can do it. It's a calculator problem. Don't do it by hand. Oh, then we need to do it? No, I don't. Yeah, I do. Well, the window, you could do a zoom fit because they do give you the domain. So guess what? Oh, I'm in the right mode. So I got to put this. Now, what's the other thing you have to worry about with your mode? Being in what? Being radians. Okay. So y equals clear. Now be careful that you type this in correctly, because it's so easy to type it in wrong. And it's sine of e to the t. By the way, once they reference second e to the t, once they reference the function, they call it dy dt or dx dt. You don't have to write that whole function down. You can just say dy dt is 0. Okay, and the y value, I'm going to clear that out. No. Yeah, we will. I just don't know where it is right in a second. That's okay. We'll do that tomorrow. And do what L'Hopital's rule tomorrow. There's a lot to get done. Yes. These are the derivatives, yes. Nope, it doesn't matter. Or I might even want to put it into the regular one. I don't really know that I care about that. I just want to know where this is 0. Matter of fact, that might be the easier way to do it now that you mention it. If you wanted to graph this for t between 0 and 1.5, do you want to see what it looks like? So I'm going to do, I want to look at the table, second table set, and I want to go 0 to 1.5. Well, it's not too bad. 11, it's 12 to 3. I could graph it. And I goofed. I really should have just taken this and changed my mode back to function mode. So I think it's easier. My calculator's being fussy. At least it works. So in y equals, I want to clear this out and put in, because I want to solve, I want to see what this one's 0. 14 cosine of x squared, because it doesn't matter what the variable is, times the sine of, let's see if I do it right, e to the t squared. No, it's just e to the t. It's the wrong one. Oh. I want to do it in this mode because it's easier. Now, what's the biggest this is going to get to be? And I don't really care, by the way, because I just want to see the zeros. So on my window, I'm going to go from 0 to 1.5, correct? Yes. I'm going to set it exactly equal to that. Whoops. And then I don't even care what the y mins and max are. I just wanted to go from negative to positive. What theorem am I using? Hello? Close, but not quite. I'm looking at the intermediate value theorem. If I have my min go from -1 to +1, it will change signs. It has to go through 0 on that interval. I don't care. There may be more than one answer. Oh, there are two answers. So I do second calculate, and I want to find the zeros. And I could do 0, and then I'm going to have to enter probably not being nice to me, or I'm not warm enough or something. Let's see. We had 1.5. Let's try 1. And let's see what happens. No sign change. Intermediate value theorem failed. I just have to get over there to the right, and I didn't want to do it. Okay, so we are going to do second calculate. And this happens on the exam. I'm going to try for 0. And I guess I'm going to have to go over here until I see the cursor. Should be coming down. I probably didn't go far enough. I hate this. There it is. Finally. But at least we can do it. On the T81s, you actually had to zoom in on them. There was no other way. But now we'll be all set. There's 1, 0. When in doubt, include all the decimals, and then we'll do second calculate and find the other one. We're going to start there, or actually go a little bit to the right. Since we see the cursor, it's not a big deal. So there are your two values. I would write all the numbers. You have to have at least 3. Here's the deal. You write all the numbers, you mess up on the last number, we don't care, we don't look there. We only look for the first 3 decimals. That's it. So it's 1.144. You could make it 1.145. It doesn't matter. And this one's 1.253. And that's the only choice. This is the x value. I want to find, and in this case, it's the t value, because I graphed this. That's a good question. It's 14 cosine, because they're dummy variables, x squared sine of e to the x equals 0. Those are my two values. These are the x values, in which case they're actually the t values, because that's what it asks for. It says, find all values of t. So instead of x, I'm going to put in a t. My guess is it's 3 points, but I could be wrong. It could only be 2. I don't know. 1 point for making this statement, 1 point for that t value, and 1 point for that one. And if I knew what year it was, I'd bring it up, but it'll take me a second to find it. I mean, I can find it. Okay, find the slope of the line tangent to the path of the particle at t equals 1. Well, that's easy. How do you find the slope? It's dy dx, which is dy dt over dx dt. And I want to evaluate it when t equals 1. Guess what? I'm pretty sure you get a point for that statement right there, which is nice. Okay, what's dy dt? This isn't hard. It's just a little putty. All over dx dt. Must you use a calculator? No. Honestly, I could figure it out, but let's let t equal 1. This is 1 plus 2 times the sine of 1. Done. This, make it squared even. This is 14 cosine of 1 squared sine, whoops, sine of e. That's one way to do it. On my calculator, I had, what did I have? dx dt was my y1. And then I would put dy dt into y2. And then I would use the calculator to do y2 of 1 divided by y1 of 1 if I wanted a decimal answer. Do you want me to do that? I have no idea. So let's put the other one in. I'm not even going to use the graph. What's the other one? 1 plus 2 sine of t squared. Okay? I want y2 over y1. So I'm going to quit, and I'm going to go vars, because many of you do not have the new operating system, divided by, oh, I got to put in 1, divided by, but see, once you start doing this, you're opening yourself up for mistakes. This is one way to do it. There are other ways. This, I would do it this way, unless they say give us an approximation, in which case then you have to do a decimal. How do you find the acceleration vector? This bothers you for some reason. I want the acceleration in the y direction, which is dy dt, the derivative, sorry, said it wrong. It's, okay, d squared y dt squared. And I want the acceleration in the x direction, dx squared dt squared. And I'm going to do my calculator on this one. So I'm going to do n derive. Remember, now the y was in y2, right? And the x was in y1. I don't like that, but. And so we're going to do n derive at t equals 1. Now, let me show you the alternate way to do this, because I don't want to use that function notation. So why don't I just take 1 and store it in place of t, I'm using x. Put it in for x. Now, when I do n derive, I could actually do x. So it's 8, right? I'm in pretty print. Sorry. That's x. This is going to be, x was in y2, right? Since I'm in this, if you can pick it up through vars, or you can go alpha calc, and y2 is the second one. I wish I had numbers on that, but you have to arrow down. And we're going to do this at 1. Now, what you guys did on your final exam is you did it by hand. You guys are crazy. Where'd this guy go? This is d squared x dt squared. Could you take the derivative by hand? Yeah, but why would you? You guys did, and guess what? Most of the time you did it wrong. Can you find the second derivative for y? I don't know why they had that as a bonus. Write equation for the line tangent to the particle at t equals 1. How do you write the equation of a line? Y minus y1 equals m x minus x1. Oh, I know why it's bonus. You can't do it yet. You have to integrate that. I don't want to do it today. It'll mess you up. You have to integrate it. Do you want me to get the second derivative for the y value as well? So let's see. To do that, let me change my mode so I'm not in pretty print anymore, so I do it the way you guys see it. If you have an 84 calculator and have not changed your calculator operating system, let me know and I'll help you do that. So I'm going to go math 9, and this was in y1, no, y2. We'll find out. I'll get the same answer. Comma, x, comma, 1. And they could have said x. Whoops. Oh, not FNING. Derive. 8. There we go. Oh, I did the same one twice. I better get them labeled correctly, though. So I'm just going to go back up here. I'm going to second enter and just change this to Y1. And I better label them with the right ones. So this one is A sub Y, and this one is A sub X. They use these funny looking parentheses. Who cares? They don't care. Oh, we still have time. Wouldn't hurt you to do the back side. Just a good review of Taylor. I think maybe we'll do that. So for homework, do the one problem, and then try working on the back side. That's 15 minutes. 15 minutes for one problem in your homework and 15 minutes for Taylor. That's a half hour. Unless you're going to go to the hockey tournament, you should have reason to get it done. Or is there a basketball game? Who are they play? The Gophers are playing tonight? Who's Minnetonka playing? Did I miss you? I'm sorry. Yeah.